Okay, so today we are going to start our discussion about energy. And we're going to follow the law of conservation of energy. Which states that energy cannot be created nor destroyed. When you're talking about this concept of energy, we have to think about, in order for us to follow the law of conservation of energy, there is going to be a system and there is going to be a surroundings. In chemistry, oh my goodness. The system is the reaction, meaning it is just the identity of the reactants, and the identity of the products. Everything else is the surroundings. So in other words, the water for an aqueous solution, that water is surroundings. The beaker that the reaction takes place in, or the test tube, or whatever, that glassware, or the styrofoam cup, that is surroundings. The thermometer we stick in this to measure this heat is surroundings. The air is surroundings. Literally, if it's not the reactants and the products, it is the surroundings. Now, when we think about energy, most reactions, not all, but many reactions require a spark to get the reaction going. An example, when you are driving a vehicle, you have to click that starter to provide the spark to burn the gasoline. Therefore, you are adding energy to the system. At that point, the system is gaining energy. Now, once that system once that burning of the octane gets that spark, we know that that reaction continues. And it helps us to move the vehicle. So therefore, the system loses energy to the surroundings. The burning of the gasoline loses energy and forces the car to move. The car being the surroundings. Now, you will notice I included some signs here. Positive simply means, it doesn't mean that it has to be a positive value. What positive means in the world of energy with respect to what we're going to be describing is that you had to add energy to the system. And so the system gained energy. Whereas if you have a negative sign, energy is lost by the system. That is what our sign terminology means. It does not mean that the system's energy is going to go negative. It doesn't mean the system's energy is negative, because you can't have negative energy, folks. You either got energy or it's zero energy. You can't have a negative number. So what it means is the directionality of this energy. Now, as I mentioned in the laboratory, energy is equal to the heat plus the work. This heat can be described using the equation mc delta T, where m, as we described, is mass, C is the specific heat of the object or substance, and basically the specific heat describes how much energy is needed to raise the temperature of the substance, or the to raise 1 gram of the substance, raise the temperature by 1 degree Celsius. Let's think about this. Every substance has its own specific heat. If we stick an aluminum pot on a stove, we turn it on. It does not take long for the aluminum to heat up. Now, if that aluminum pot contains water, though, it seems to take forever for that water to heat up. That's because aluminum has a very low specific heat. It doesn't require that much energy for 1 gram of that aluminum to be raised by 1 degree Celsius. Whereas water has it has one of the higher specific heats at 4.184 joules per gram degree Celsius. It takes 4.184 joules of energy to raise 1 gram of water by 1 degree Celsius. That's what we mean by specific heat. And again, those constants can be found in table, and you would be given them on an exam. Now, can't remember on the homework, I think I give you the specific heats, except for waters. But if I don't, you can Google it, because again, it's a constant. And then delta T, delta, folks, delta always means final minus initial. So delta T, as we talked about in lab, is the final temperature minus the initial temperature. So let's look at a problem. A 15.75 gram piece of iron absorbs 1086.75 joules of heat energy and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific heat of iron. Okay. One of the things I find very useful when dealing with specific heat problems is to make a list of information that I was given. First of all, I know that I'm dealing with iron here. That's my substance. I was given the mass of the iron as 15.75 grams. And I was told that it absorbs 1,086.75 joules of heat energy. Folks, this is where it's important to understand those signs. If the system is absorbing energy, what should the sign be for the heat? Positive. So it's a positive 1,086.75 joules. And the temperature changes from T initial of 25 degrees Celsius to T final of 175 degrees Celsius. And we have been asked to calculate the specific heat. We have one, yes.
I'm sorry, just can you write like a little bit bigger?
I can try. I'm also trying to fit the problem onto a page, but I will do my best. Now, there is only one substance here. Because there is only one substance here, you need the form, and we're talking about calculation of specific heat. You need the formula Q equals MCAT. Again, because we're talking about only one substance, and you need specific heat, you need the equation Q equals MCAT. Now let's fill in this information. Q, let me scroll down then so I can write bigger. Q was a positive 1086.75 joules. That is equal to the mass of 15.75 grams times the specific heat, which is what we want to solve for, times the change in temperature, which is final, 175 degrees Celsius, minus initial of 25 degrees Celsius. Ten 86.75 joules, therefore, is equal to come on. Two 2,362.5 grams degrees Celsius times the specific heat. Dividing both sides through by the grams degrees Celsius. You get a specific heat of 0.46 joules per gram degrees Celsius. Questions? Is that better? Okay. Okay. Now, in order to follow the law of conservation of energy, we can say that heat of the system would equal a negative heat of the surroundings. Here, the value Q is the same. It is the sign. That is different. Again, you cannot create nor destroy energy. That's why Q is the same number. But if it is added to the system, that means it had to leave the surroundings. So they have to be opposite in sign in order to follow the law of conservation of energy. Now, we said that Q is equal to MCAT. So we can say that MCAT of the system is equal to a negative MCAT of the surroundings. Yes.
Will there be some scenarios when the energy going into the system is the one, or is the one that's negative, like the energy in the surroundings is positive? Like,
Okay.
it's not
So basically, I was just asked, can these signs be flipped? This be negative, that be positive? The answer is yes. But for the equation purpose, it doesn't matter who you make positive and who you make negative, it's going to come out in the wash.
so they're just opposite.
They just have to be opposite. For the equation purpose, they just have to be opposite in signs. Because as long as you do the algebra correctly, everything will come out in the wash with the correct value in the end. Now, some things to note, mass can't be negative. Specific heat can't be negative. Your individual temperature units cannot, well, no, I'm not going to say that. They can be negative because we're dealing with degrees Celsius. But mass will not be negative. Specific heat will not be negative. If you get a negative mass or a negative specific heat, you know you've done something wrong. Okay. Let's talk about when we use this equation. First of all, you will have two substances. And you will have discussion of specific heat. That is how you're going to know, hey, I need to use this variation of the equation rather than the other one. Because that first equation I gave you, we dealt with one substance and specific heat. This equation, you'll deal with two substances and specific heat. So let's look at an example. Okay. Determine the final temperature when 450.2 grams of aluminum at 95.2 degrees Celsius is placed in an insulated container with 60.0 grams of water at 10 degrees Celsius. The specific heat of aluminum is 0.900 joules per gram degree Celsius. And that of water is 4.184 joules per gram degree Celsius. Keeps changing my joules per gram degree Celsius. It does not like it. Okay, folks. One thing we haven't discussed that you need to know in order to do this problem is that heat is transferred from the hotter object to the colder object until the temperatures are the same. This is going to be important for us to be able to answer this question. So again, with respect to this question, I am going to make a list of information I've been given. First of all, I see aluminum and I see water. I have two substances. I have aluminum and I have water. Now, the aluminum has a mass of 450.2 grams, whereas the water had a mass of 60.0 grams. Aluminum had a specific heat of 0.900, that's joules per gram degree Celsius. And water has a specific heat of 4.184 joules per gram degree Celsius. We were asked to determine T final, which will be the same for both. And we were given T initial. For the aluminum, it was 95.2 degrees Celsius. For the water, it was 10 degrees Celsius. Two substances means Q of the system equals negative Q of the surroundings. Since Q is equal to MCAT, it means the MC delta T for the system is going to equal a negative MC delta T for the surroundings. Folks, it really doesn't make any difference, again, who you make the system and who you make the surroundings. It will all come out in the wash. The main thing is that they are opposite in sign. Now, filling this information in, and this I'll have to write smaller in order to get it all in. We had 450.2 grams of aluminum times 0.900 joules per gram degree Celsius times T final minus T initial of 95.2 degrees Celsius. That's equal to a negative mass of water at 60.0 grams times the specific heat of water of 4.184 joules per gram degree Celsius times T final minus T initial of 10 degrees Celsius. Multiplying 450.2 times 0.9, you get 405.18 joules per degree Celsius times T final minus the 95.2 degrees Celsius. That's equal to a negative 251.04 joules per degree Celsius times T final minus 10 degrees Celsius. Usually using distribution, that means it is 405.18 joules per degree Celsius times T final minus 38,573.136 joules is equal to a negative 251.0. Let me put it on the next line. A negative, stop, 251.04 joule degrees Celsius times T final plus 2510.4. Rearranging this equation so like terms are on the same side. You get 656.22 joules degrees Celsius times T final is equal to 41,083.536 degrees Celsius or joules. Dividing both sides through by the 656.22, you get a value of 62.6 degrees Celsius. I'm letting everybody write it down and then I'll walk you through it. Lots of algebra. Yes.
So you just added the 251.405 to get to the 66.
Correct. Okay. So I put in all the data into my formula. MCAT is equal to negative impact. For the aluminum, I multiplied 450.2 times the 0.9, and that's how I got 405.18. That is multiplied by the T final minus the T initial. On the right-hand side, I multiplied a negative 60 times 4.184 to get a negative 251.04 joules degrees Celsius. And that is still times the T final minus 10 degrees Celsius. I then use the distributive property. So 405.18 times T final gave me this piece. 405.18 times negative 95.2 gives me this piece. On the product side, I did negative 251.04 times T final to get this piece. And I did negative 251.04 times a negative 10 to get the positive 2510.4. When I say combine like terms, this term and this term both have T final in it. And this is, remember, after the equal sign. So in order to move it from the right-hand side of the equation to the left-hand side of the equation, I added 251.04 to both sides. In adding adding the 251.04 to the left-hand side, you got the 656.22. Adding 251.04 to the right-hand side, this piece disappears. I did the same thing for the joule. You have a negative 38,573 joules here. To get it moved to the right-hand side, I added 38,573. This cancels out this side, but added to the 2510.4, you get this number. You then divided both sides by 656.22, and you got your T final. Questions? Get comfortable with this type of problem. Yes. 38,000 came from multiplying 405.18 times negative 95.2 to get the negative 38,000. Hint, get comfortable with this type of problem. Other questions? I don't have time to do another one of these problems. So what I will do on Thursday is I will talk about enthalpy, and then we in the laboratory learned how to calculate the enthalpy of the reaction using specific heat and the moles of material. That is how you would do it if you're in the laboratory. On Thursday, we're going to learn 2 ways to calculate enthalpy from data that you can pull out of a textbook. And that is through Hess's law and through enthalpies of formation. I will see you on tomorrow. Don't forget to get your gas law lab grade. You've got to be there. There's actually a 25-10. If I miss, it's all in. So, I mean, up to the 20 points allotted. So if I miss it, email me. Because I try not to, but it was acting weird when I was putting in stuff on yesterday.
I saw the very bottom was where it was. I saw 10, but yeah, I'll remind you.
I literally have something else to
I gave you the formulas.
Okay.
Oh, as far as it's okay. It's okay. We're gonna make things. Yeah.
So
Yes, I will do that. Basically, I will.
That's
do
smart.
more.
What she said, that's what she did.
Exactly what each column is, but that's it, I'll show it on Blackboard. I have columns already done, I did one.
Okay, and you're only making 10 minutes, so I'm gonna watch it. But it's okay, we gonna get it, we gonna get it later today, and we're not gonna do it. All right, you're looking.
Oh, she's struggling with it. Wow.
Good. That's why I have a couple of things. But like my first one, like, I already calculated, I wanna get to Thursday, when they have, I have to just-
For me, it's if you don't come and ask questions. If you don't ask the questions, I can't help you. And so I would love for you to come see me. I can help you work through some of these problems. I know you're a busy person, but, you know, today I'm available from 11 to 1. Tomorrow, as of right now, I'm available 2 to 4. But I expect lab to get out early, so therefore I'll be available longer. Thursday, I don't know my schedule. It's a little hairy, so I can't tell you when I'll be in my office Thursday. I don't have anything. No, I just finished 2 classes in a row, so I'm done.
So today, 11 to
Right, 11 to 1. So basically, I go upstairs, get a brief drink, and then we can go. So I can help you out. And it's easier for me to walk through an individual. I mean, I try to walk through the math, but if you're struggling with the algebra, then let me work on the algebra. I also have, like, if it was the stoichiometry that was getting you, I do have some videos related to stoichiometry that you can watch as many as you need. So there's a lot of tools that I can possibly pull from.
Are the use of
I don't remember if I posted them for this class. But it's literally a Word document with a gazillion videos that you can watch as many as you need just to try to pick up on some of the little cues. And it's mainly dealing with stoichiometry. It doesn't deal with this, even though I do have a video that walks you through this too. So I could pull it out as well. Let me see if I can't work through some of these. Friday, can I even come in on Friday? Some Fridays I could come in. I don't know my schedule for this Friday. Okay, this Friday I could come in an afternoon and maybe do some extra help. You just gotta email me.
Yeah,
So
I
that-
I know she said. I want to be like, girl, you keep going to the office.
I don't mind you coming to the office. I'm not one that gets all upset about, I love people coming to office hours. So,
That's what I was telling her, like, she's not gonna try to work.
no. And basically, while she's working a problem after we've discussed a little, a lot of times I'll do something so that I'm not, I try not to make you feel like I'm this watchdog. And so we'll talk about what's the question, and then she'll work a couple of problems on her own, and I'm sitting there in case she has a question, but I don't cover.
Fridays. Thursday, I do have a study session for physiology, but I could do today.
Thursday is bad for me.
Yeah.
I barely have any time, so Thursday is bad, but the rest of the time, it's fairly open. And Friday, like I said, if you just email me so that I put you on my calendar, because I put people on my calendar if it's not my official office hours. Okay, bye. I know it's scary. I was scared to in college. I never went to see professionals. It's hard for me because it's scary.
It was just crazy. I just like. That's why I went to. But I'll probably go today.
Okay, well, I'll be up there until 1.
That's what you thought about. This is about. And I need to help decide about attention, like attention forever, I should do.
Okay, well, we can go upstairs and discuss it. I'll try to.
Let me close out so that Dr. Kumar, right? Yep. Okay. I thought I had the right class. I never promise anything anymore.
2 classes in a row, that's crazy.
It is, but it's, and sometimes it's a challenge, me trying to keep up with where I'm at in which class,